So my role is very small here. It was just a few slides just to introduce you to the MRSEC. And then I was going to pass it over to Rudy. We've been collaborating with IBM for about 16 years now on an intern program. So just to give you an idea of one of the programs that we have with that. Let me give you a little bit of a history of the MRSEC. So the MRSECs are Materials Research, Science and Engineering Centers. They're NSF-funded centers, about $20 million centers. They run for 6 years, and then you have to apply to get it done again. University of Chicago is one of the oldest MRSECs. We started our MRSEC in the 1960s. So what we do then is for every 6 years, we have to kind of reinvent ourselves, right, and look at how can we sort of push the next boundaries of science, education, and outreach, right? So this is what NSF is really looking for. There are 19 MRSECs across the US, and as I said, we've been one of them. One of the things I wanted to try and do today is probably the main things that the MRSEC does. About a third of our budget is focused on buying new equipment, so state-of-the-art facilities. So we spend a lot on equipment, making sure that we're staying right at the cutting edge of the facilities. And Justin Jeweler, who's at the back there, give a wave, Justin. He's the person who runs our facilities, and you'll get a little bit of a tour this afternoon on this. To give you sort of an idea of some of the areas that we work in, we have sort of 3 focus areas right now, and we switch these around every 6 years. But right now, one of our major focus areas on how can we think about training materials. So you train your body in different ways to get to optimize for a given task. So if you're a weightlifter, you have a very given training protocol to optimize your weightlifting. If you're a runner, it's a different training protocol, but it's the same body, right? We've been thinking about how maybe we can rethink polymers. So rather than having, say, 20 different polymers to do all the different things, can we think about generating things like pluripotency in plastics? So think about this as the analogous to a stem cell, right? So a stem cell can be turned into any kind of cell based on chemical and mechanical cues in the body. What if you could do this with one plastic, that you could make it into a rubber or a glass or a tough plastic, right? We've got technology that can do this now. Think about how that alters your thinking on recycling, because if every plastic is made of the same material, you don't have to think about mixed waste plastics. So a lot of these ideas, we're trying to push the boundaries of how we think about materials, and that was just one example of this. For the sake of time, what I really wanted to do was to try and talk a little bit about how we might engage with industry, and we do in a number of different ways. By definition, the MRSEC is designed to be very fundamental research. That's what NSF requires this to be, right? So we're very fundamental, trying to push the boundaries of what we think. That doesn't mean, of course, that there's not a lot of what's going on in a lot of our labs that trickles into much more I should say, industrially relevant research. However, right, that might not be the way that you engage with the MRSEC. It can be, but what we also do is we do a lot of outreach to the local community. We partner with companies to do that. We do a lot of outreach to, sending our students to companies a lot. And I said we've been doing this. We're a lot older than the PME, right? And it was really the hub of materials research was the MRSEC until PME came along. Now, about half the PME faculty, half the MRSEC faculty, which numbers about 40 faculty, right? From chemistry, physics, and PME. About a third of our faculty are in physics, a third are in chemistry, and a third are from PME. So it's a very interdisciplinary mixed group that we have. So what I wanted to do then was just sort of introduce Rudy as someone that we've been collaborating with, or IBM we've been collaborating with for about 16, 17 years now on this internship program. And Rudy will be the one that will detail how that's worked for IBM and what they've got out of it.